Good afternoon, pilot teachers, and good afternoon, students. Thank you. Sit down. Okay, our lesson today will see us now move on to the last of those four components of a good map, and that is looking at scales. Remember, we started off at the beginning by looking at a good map should contain heading or a title. For the heading or the title, we did not do much work with it because straight away, whenever we pick up a map, that's the first thing we should be looking for, the heading or the title of that map. So a good map should have a title or a heading. Secondly, a good map should have directions. And in directions, we did a little bit also on bearings, and I mentioned that. Bearings is another way also of giving directions, only that in directions, when we use the 16 points of a compass, sometimes the information given is not going to be very accurate, whereas in bearings, we can be very accurate with our information. Then we looked at keys and symbols also, as they're important. They are supposed to represent features on maps. And finally, but not the least, the fourth component of any good map is that good maps must contain a scale. So today we will move on to looking at scales, and our objective, what we expected to at least learn by the end of the lesson, is to be able to interpret the three different ways in which scales are actually shown on any topographic maps or maps. Yesterday we looked at grid references also, and with grid referencing, we learned about how to use the 4-figured grid referencing and the 6-figured grid referencing to identify or locate items or features on a map. Okay, we'll move on. Looking at scales from the handout or the worksheet that you have, we're going to continue on. And the introduction to it tells us that scale is the ratio between a distance on a map and the actual distance on the Earth's surface. The reason for why we need to use scale on maps would be, one, it can be used to calculate the distance between places. And secondly, to decide on the detail of the features of the Earth's surface which can be shown on the map. Those are the two reasons for why we need to use or why we use scales on the map. Most of the time when we're using scale, it will be mainly to do with the first of those reasons, and that is using it to calculate the distance between places. So a definition of scale is already given there from your worksheet also and from the monitor. Also note that scale is very useful to map makers because it enables them to put a map of a whole country on a small piece of paper, such as one of the pages in your atlas. You need to know the scale of the map so that you know the size of the place or the country that that particular map is showing or shows. And nearly all the maps have a scale, and they also show the scale in one of the three ways. So here are the three ways now that scales can actually be shown on any maps. You could have a map that can contain all of those three ways, or you could have a map that will have one of those three ways. But however the scale is shown, we should be able to interpret or read the scale correctly so that we are able to calculate the distance if we are asked to do so. So the three ways in which scales are actually represented or shown on any map could be the first one in the form of written words. And when scales are given in the form of written words, then we say the scale is given as a statement. An example given there as a statement, a scale of 1 centimeter to 1 kilometer, or 1 centimeter to 500 meters. You will see that the scale itself is in a statement form. It is in written words. And this is one way in which scales can actually be shown on any map, in written form or a statement. The second way in which scales are represented on any map or on a map could be in the form of what we call representative fraction, or RF. RF simply stands for representative fraction. And a scale given in this form will be in the form of a fraction of 1 over a number. And in the 3 examples given here, we have a scale given in representative fraction of 1 over 25,000. Another scale could be 1 over 100,000 or 1 over 50,000. And it tells us here that the numerator, that is the 1, represents the number of units of the map or on the map. And the denominator represents the number of that same unit on the ground. So if it is 1 over 25,000 and we wanted to use the unit centimeters, because centimeters would be a more appropriate measurement to use on our maps or atlases. Imagine if we said 1 meter, then those atlases would be very big. So a centimeter would be the most appropriate measurement of the maps that we would be using. So let's imagine that the unit of measurement is 1 centimeter that's on our map. It will mean that 1 centimeter, if the RF is 1 over 25,000, 1 centimeter on the map will represent 25,000 centimeters on the ground. That is what the scale is supposed to show when it is an RF. If it is 1:2 or 1 over 100,000, it will mean, if I use the centimeters, then 1 centimeter on the map will represent 100,000 centimeter on the ground. Similarly, if it is a scale of a representative fraction of 1 over 50,000, it means 1 centimeter, if I'm using centimeter, is 1 centimeter, on the map represents 50,000 centimeters on the ground. And that is what the representative fraction is supposed to tell us or show us. Whatever unit of measurement that 1 is representing, it is equal to that same unit of measurement on the ground. So if it is centimeters, then it would be so many of that centimeter on the ground. The 1 represents on our map the numerator, that is, and the denominator represents that unit on the ground or in reality. Representative fraction can also be written as a ratio. It can be given as a fraction of 1 over a figure, or representative fractions can also be written as a ratio. And when you see that ratio on a map, for example, if it is a map with a scale of 1:100,000 or 1:25,000, we need to know what that means or how to actually use that scale so that we can calculate our distances. But with the representative fraction, it can be written as a fraction. It can also be written as a ratio. Okay, and here it tells us that the map distance is started first and is again always, is stated. I'll repeat that. The map distance, which is the atlases that we're using and etc., is stated first and is again always the number 1. Say in the case of 1:100,000. That 1 is supposed to be the map distance. The map distance will always be stated first, and it is usually represented by the number 1. Both the map and the ground distance or distances need to be stated. This is important, need to be stated in the same units. And topographic maps usually show the scale as a ratio at the top of the map. So you get a map, you open the map, and then you will see at the top somewhere it will give you a scale, whether it be in statement form or whether it be in a representative fraction or a ratio. Okay, we'll look at how we can interpret those when we do some activities. That so far, we've looked at two ways in which scales can be written or put on maps. The third way in which scales can be actually drawn or put on maps would be in the form of a line scale or a linear scale. And here, when you open the maps or when you look at the map, you will see a line drawn, and the line is drawn to scale. So what you do here is you simply maybe pick a piece of paper, you measure the distance between the 2 points, or you use your ruler, measure the distance between the 2 points, and then put it against the linear scale, and then you are able to tell the distance. So let's go back and look at the three ways in which scales could be actually shown on any map. The three of them could be shown, or one or the other could be shown on the map. The first one is that scales can be written as a statement. Example 1, in written form. Example 2, scales on map can be given or shown as a representative fraction, or RF, of which it is a fraction or it could be a ratio. And number 3, scales could also be shown as linear scales or a line scale, as in the example given here. One of the things that we need to remember when we are actually using the scale is that we must ensure that we interpret the scales correctly. If we don't interpret the scale correctly, our measurements will not be correct of what we are giving. Especially when we are looking at the representative fractions or the ratio, it tells us here at the bottom that both the map and the ground distances, when we are dealing with the RFs or the ratios, need to be stated in the same units. And if they are not given in the same units, then what we need to do is we need to do some converting so that our conversions will get our measurements to the same unit. And when we have them at the same unit, we are able to calculate our distance. So we are going to do some work now, and we'll start off with looking at statements and then seeing if we can interpret the scales correctly using the statements. Activity number 1. I'd like you now to see if you can express the following scales as a statement. There's 6 of them. Most of them, or 3 of them, sorry, are given as a ratio, and the other 3 are given in fraction. So what you need to do now is to write so that they're in statement form. You express those different scales that are given. The first one, 1 is to 250,000, express that as a statement. 1 is to 100,000, express it as a statement. 1 is to 50,000, 1 over 25,000, 1 is to 2,500, and 1 over 200. Express those as a statement. So that means you have to write it in written form.
Does it have to be in centimeters? For instance, this over here, centimeters, 1 centimeter is
To 1 kilometer. Okay. If you want to put it in that form, that's fine. Only that make sure you are able to convert that, yes, into, at this point in time, yes, exactly. You see, if you look at it at this point in time, if you say 1 is to 250,000, if you had to write that as a statement, what would you write down?
It has to be in the same unit.
At this point in time, when it's given in a ratio form, it's already in the same units. So if you decide that 1 will be a meter, that means 250,000 must also be a meter. If you decide that 1 is in centimeter, then 250,000 is already in centimeter. So as it is, it's already in the same units. But if you want to make it so that it will, if you want to change it so that it will be more practical, like instead of using 250,000 centimeters, you might want to use meters, or you might want to use kilometers. And then that's when you need to do some converting so that you can get the correct conversion for how many meters are there in 250,000 centimeters. How many kilometers are there in 250,000 centimeters? And it must be correct according to what is given there. You have a question? Same question? Moving in. Did you hear my explanation? Okay. All you are doing is you're expressing those scales in a statement form. That means you have to put it in written form. Okay, as it is, like I've explained earlier on, as it is, that 1 is supposed to represent the distance on the map. That 250,000 is supposed to represent the distance of the same unit on the ground. So if you have to write it as a statement, you can leave it as it is and write as a statement. But if you want to change the units so that instead of 1 is to 250,000, of which if 1 is 1 centimeter, what do you think would be the 250,000? In what unit should it be? No, it's centimeters here, because if it is 1 centimeter to 250,000, it will have to be the same unit, centimeters. Okay, you can convert it. If you don't want to say that 1 is to 250,000 centimeters, but you'd rather use meters or kilometers, then you'll have to change the 250,000 centimeters to meters, or you change the 250,000 centimeters to kilometers. So you can say 1 centimeter is equivalent to so many meters or so many kilometers. So whichever you do, it will still be okay, but your answer must be the same. Okay, maybe I'll need to explain a little bit more on this one, since a lot of students are having the same questions here. If you look at our scale as it is now, it's given as a ratio and it's also given as a fraction. If you were to write a statement on those, already I mentioned that 1 is the distance on the map. So on the map, it would be more realistic to use the unit centimeters. The second lot of numbers given, or the denominator given for the fractions, they represent the same unit of measurement if you are giving that as 1, or if you're giving that, as a centimeter, but on the ground. So if you had to write that as a statement, maybe we'll give an example. If you have to write that as a statement, you would have said that it is 1 centimeter to 250,000 centimeter, full stop. Okay, some students are now saying that, could we convert and could we change that 250,000 centimeters? And my answer or my reply is going to be yes. But if you do change, make sure you are converting it correctly to either meters or kilometers. So let's do the first one together so that will help you. Say, for example, if I wanted to say 1 centimeter is equivalent to so many meters, what do I need to do here to change this 250,000 centimeters to meters? I divide by 100,000? 100. You divide by 100 centimeters? Okay, I'm trying to change, wait, first of all, that 250,000 centimeters to meters. To meters. I divide by 100. Okay, when I divide that by 100, I will be left with 2,500 meters. Okay, then I would have to put that as a statement. If I wanted to change this to kilometers, instead of saying 1 centimeter is to 250,000 centimeters, I would want to say 1 centimeter is equivalent to so many kilometers. Then what do I need to do? I need to divide this by 1,000, 10,000. How many centimeters are there in 1 kilometer? 1,000? No. 100,000. There are 100,000 centimeters in 1 kilometer. So therefore, I divide this by 100,000. And when I divide this by 100,000, what would I end up with? 2.5 kilometers. So if I had to write it as a statement, then I will say 1 centimeter is equivalent to 2.5 kilometers. You see that? But before I can do that, I need to do the converting, depending whether I'm converting to meters or whether I'm changing this to kilometers. Make sure your conversions or converting will be the correct and the same as what is given for the ratio or the fractions. Obviously, whenever you're writing a representative fraction, you must make sure you write the fraction of the same unit or the ratio to the same unit. So therefore, 1 centimeter to 1 kilometer are two different units, centimeter, kilometer. So you have to change that to, change this kilometer to centimeters. So how many centimeters are there in 1 kilometer? For the first one, did you work it out to meters? 1 is to 250,000. When you change that 1 is to 200, if you change it to meters, what do? We divide by 1,000 or 100? What do we divide by? I'm asking you, is it 1,000 or 100? For which question? For the first question, if you're trying to divide or to change those to meters.
Divide by 100.
Why 100?
100 centimeters in a meter.
Okay, maybe we'll check on those since we'll double check. Double check, and you're okay with yours as it is? Sorry, girls, excuse me. 1 centimeter is to 5 meters. Is this 25 meters? Yes, okay, that's good. 1 centimeter is to 2 kilometers. Where is it? Where is that? Okay, so 1 over 200, you're saying that 1 centimeter is to 2 kilometers? How many kilometers are there in, how many centimeters, sorry, are there in 1 kilometer? How many centimeters are there in 1 kilometer? 100, no. I'll repeat the question. How many centimeters are there in 1 kilometer? No. It's 100,000. So you cannot say that 1 over 200 is 1 centimeter is to 2 kilometers, no. Because there are 100,000 centimeters in 1 kilometer. So you'll have to double check on the last one. Okay, all you're doing is you're writing those scale into a statement form. So that means I explained to you that if you have a scale of 1 is to 25,000, that is in ratio form. That's a representative fraction. But what does 1 is to 25,000 mean? It means that one of whatever unit we use on the map is equivalent to so much or many of that unit on the ground. So the unit must be the same if we are using a ratio or representative fraction. So for the case of this one, if it is centimeters that you are going to use, because it's more practicable for us to use centimeters on maps, then that 1 centimeter would be equivalent to 250,000 centimeters on the ground. Okay, if you don't want to use the 250,000 centimeters, you need to convert the 250 centimeters to either meters or kilometers. And if I have to change maybe to meters, I would divide by 100. If I had to change to centimeters,
100.
if I had to change to kilometers, then 100,000, because there are 100,000 centimeters in 1 kilometer. So I simply divide that, if I'm using kilometers, by 100,000, and I end up saying that on that map, 1 centimeter on the map is equivalent to 2.5 kilometers on the ground.
Okay.
And similarly, I do the same. I could leave it as a statement as it is, or I could do the converting so that the units are different.
Okay.
At this point in time, you leave it the same units, you have no problem, you can convert. But if you want to change the units, you'll have to have the different units, but make sure you do the converting.
Am I on the right track?
1 centimeter to 1 kilometer. That is B. 1 is to 100,000, correct. You've done the converting, because when you convert 100,000 centimeters is equal to 1 kilometer. So you do the converting, 1 is to 100,000 simply means 1 centimeter to 1 kilometer. That's correct, so this is okay. 1 centimeter to 500 meters, okay? You're looking at meters this time, you are not putting to kilometers. So you are converting that 50,000 to meters, of which your answer will definitely be correct. So you are on the right track, yes. Okay, we are going to actually do the correction of those ratio and fractions as they are, first of all, and then for your homework, what I will ask you to do is that I'd like you to, for those people who have not done the converting, for your homework, you will be required to do the converting of these 6 activities or 6 exercises given. And then when you come back next week, I'm going to ask each one of you to explain to the class how you have actually converted and what answer you came up with when you converted or when you changed those instead of using the centimeters. Okay, as it is at this point in time, if we had to express the following scale as a statement, for the first one, I could simply write 1 is to 250,000, full stop. But making sure that I don't write the number 1. Rather, I have to put 1 as a statement. And that means O-N-E. 1, 2, T-O-O, and then 250,000. Full stop. That is already in statement form, as it is. Can you see that? Okay, good. The second one. 1 is 200,000. All I have to write in statement form is 1 is to 100,000. Full stop in statement. You see, I haven't done any converting. Your homework is going to be doing the converting. And your converting will show us what 1 centimeter is equivalent to in meters or what 1 centimeter is equivalent to in kilometers. So those would be the 2 units that you will be required to do the converting of all of those into, so that you can explain that next week in class. Let's move on. C. 1 is to 50,000. In statement form, 1 is to 50,000. Full stop. The next one, 1 over 25,000. 1 over 25,000. The next one, 1 is to 2,500. 1 is to 2,500. Or if you say 2,500, that will still be okay. 1 is to 2,500 or 1 is to 2,500 for that. And finally, 1 over 200, or if you did say 1 is to 200, that will still be correct. So we're starting from very simple, making sure we can read those in statement form. If I had to actually convert those to the same unit of measurement, then it will be 1 centimeter is equivalent to 250,000 centimeters. And that would be the second way in which we can do that, without any converting, but using the same unit. A scale of 1 is to 100,000, you can also write it down as 1 is equivalent to, 1 centimeter is equivalent to 100,000 centimeters. Or a scale of 1 is to 50,000 can be written as 1 centimeter is equivalent to 50,000 centimeters. Or 1 over 25,000 is the same as 1 centimeter over 25,000 centimeters. 1 is to 2,500, 1 centimeter is equivalent to 2,500 centimeters. And finally, 1 over 200, 1 centimeter is equivalent to 200 centimeters. That's using the same units. Okay, your homework now is to make sure you do the converting of those so that you give your answer as 1 centimeter to either a meter or 1 centimeter to a kilometer. That also brings us to the end of our lesson for today. Okay, class, if you can now stand up. Okay, to the pilot teachers, our keyword for today is RF. That's for lesson 5. You can add that to your checklist. Good afternoon and thank you, students.